Hi friends, welcome back to my channel. In this video, we will discuss about normal distribution. If you are new to this channel, please consider subscribing and click on the bell icon to get notified. So in this video, I will try to cover the following points. So the concepts of normal distribution with some examples, the properties of a normal distribution and how it differs from other distributions, how to calculate the mean and standard deviation of a normal distribution, how to use set table to find the probabilities of a normal distribution, and finally we will do a practice problem, a calculation and a solution of the same. So let's get started. What is normal distribution and what are the examples of normal distribution? The normal distribution is a probability distribution that is commonly used in statistics. So it has a bell shape and it is symmetrical around the mean. The characteristic of a normal distribution is its shape, and it is a bell shape and it is symmetrical around the mean. The mean, median and mode are equal and located at the center of the distribution. According to the empirical rule, about 68% of the data falls within one standard deviation of the mean, about 95% of the data falls within two standard deviation of the mean, and about 99.7% of the data falls within three standard deviation of the mean. So this is called the empirical rule. There are many real life examples of variable that follow normal distribution. Some of the examples include the height of people in a classroom, the shoe size of individuals, the diastolic pressure values, etc. There are many examples. I'm just taking a few for your understanding. So what are the properties of normal distribution? A normal distribution is a continuous probability distribution that has bell shaped curve. So as we have discussed, so it has a typical bell shaped curve. It is also known as a Gaussian distribution. Some of the key properties of normal distribution include the mean, median and mode are all equal and located at the center of the distribution. That is one of the properties. And the distribution is symmetric about the mean, which means that half of the values fall below the mean and half above the mean. So the mean is located at the center and half of the value falls above the mean and half of the values falls below the mean. And the total area under the curve is equal to 1. So this is very important. The total area under the curve for a normal distribution equal to 1, and this we will be using for calculating the probability. The curve is asymptotic, meaning that it approaches but never touches the x-axis. The normal distribution differs from other distribution in several ways. For example, some distribution may be skewed or not symmetric. They may have multiple modes or peaks, or have a different relationship between their mean, median and the mode. Additionally, normal distribution have specific properties such as the empirical rule, as we stated. It is also known as the 68, 95 and 99.7 rule, which states that about 68% of the data falls within one standard deviation of the mean, about 95% of the data falls within two standard deviation of the mean, and about 99.7% of the data falls within the three standard deviation of the mean. So coming to the calculation of mean and standard deviation of the normal distribution. So normal distribution is a two parameter continuous distribution. To compute the probability of random variable under normal distribution, mean and standard deviation are required. To calculate the random variable under normal distribution, to compute the probability, we require mean and standard deviation. So let's see how to calculate the mean and standard deviation of a normal distribution. To calculate the mean and standard deviation, we need to have dataset values. So from there, we can calculate the mean by adding up all the values in the dataset and dividing that number by total number of values. And the formula for calculating the mean is sigma xi by n, where sigma is the sum and xi is the ith observation of the dataset and n is the total number of observations. So it is the sum of all the values of the dataset divided by the number of observations. And coming to the standard deviation is the measure of how spread out values are from the mean. So it just tells how spread out the values are from the mean. To calculate it, first we need to calculate the difference between each value of the mean, then square this difference, then sum them up and divide the total number of values minus 1, and then take the square root. So here you can see the formula, square root of sigma xi minus x bar whole square divided by n minus 1. So by doing this, we will get the standard deviation. Most of the cases for the calculation questions, the standard deviation and mean will be given. We just need to calculate the probability of that variable occurrence. But if it is not given, only data set is given, then we can take the mean and standard deviation, calculate from that data set, and then we can solve the problem. How to find the probability of normal distribution using set table? So set table is a table that tells us what percentage of values falls below a certain set score in a standard normal distribution. A set score is simply tells us how many standard deviations away an individual data value falls from the mean. So if a value is there, the set score will tell you how many standard deviation away the data falls from the mean. So the set score can be calculated using the formula x minus mu by sigma, where x is the individual data value, mu is the population mean, and the sigma is the population standard deviation. To use a Z table to find the probabilities of normal distribution, we need to first convert our data values to Z score using the formula above. So that is x minus mu by sigma. Then we can look up the corresponding set score in the set table to find the percentage of values that falls below the set score. So that's how we will calculate the set score and identify the value from the Z table. So let's go directly into a problem. So let's say in a class of 60 students, the average height of students is found to be 165 centimeter and the standard deviation is 25 centimeter. A student is selected at a random, and what is the probability that the height of that student is more than 172 centimeter? So this is the problem. So in this case, number is given as 60, and we already have the information of mean, that is 165, and the standard deviation, that is 25. So we need to find out, if a person is selected, a student is selected at random, what is the probability that the height is more than 172 centimeters. So in this case, we can use the properties of normal distribution to calculate the probability that a random selected student from the class has height greater than 172 centimeter. First, we need to convert the height 172 centimeter into set score using the formula discussed earlier. Z is equal to x minus mu by sigma, where x is the value we want to convert and mu is the mean. In this case it is 165, and sigma is the standard deviation, that is 25, which is already given. So substituting all these values into the equation, we get z is equal to 172 minus 165 divided by 25. So that is equal to 0.28. So we got the set score as 0.28. So next we can use the set table to find the probability that z score is less than or equal to 0.28. So when looking up 0.28 in a set table, we find that the probability is approximately 0.6103. However, since we want to find the probability that the height is greater than 172 centimeter, that is the set score is greater than 0.28, we need to subtract this value from 1. As I have mentioned earlier, the total area is 1, and we need to calculate only the values above 0.28. So 1 minus 0.6103, that gives 0.3897. Therefore, the probability that a randomly selected student from the class has a height greater than 172 is approximately 0.3897 or 32.97%. Hope you are clear with this topic. We will do more problems and calculations in the upcoming videos. If you like the video, please press the like button and share it with your friends. Thank you.